Okay, so this is section 5.3, and in section 5.3, we have to know about the formulas. If you have that formula chart, make sure you add these two formulas, please, because you need to have that on your formula chart. So get your formula chart, the one where you have right, the Pythagorean identity formulas and the reciprocal formulas and all those formulas. Get that paper and go ahead and add these two formulas, please. Okay, so then on the example that is given, let me just go through the example. That way you know how to set up the problems, okay? On example number 1, it says find the exact value for sine of 75. And then step number 1, it says find two values that add or subtract that given, that give you 75. Common degrees from unit circle. So you have to think about the common unit that is given. In this case, it's given in degrees, so you have to think about two angles that equal to 75. In this case, it's 45 plus 30 equals to 75. Then step number 2, you plug in the formula, 45 for U and 30 for B. Could it be the other way around? Sure, it could be the other way around. In this case, it doesn't really matter because community property, when you add 45 plus 30 or 30 plus 45, it gives you 75, either way, okay? So in the formula, sine of 45 plus 30, you follow the formula for sine, which is, if you look at the formula, the plus minus. If you're using the plus, then you're going to be using the plus in the middle, okay? If you're using the minus, then you're going to use the sign, the negative in the middle. If you look at the example, it says sine of 45 plus 30, you have a plus in the middle, and it's sine 45 cosine 30, because that's what the formula calls for. And then it's cosine of 45 is cosine of U times sine of 30. And then we have to know the special measurements, you know, the sine of 45 and the cosine of 30. Do you recall what is sine of 45? What you do is, if you don't remember what that is, I just draw a triangle, okay? So I draw a triangle, and I go, okay, if it's sine of 45, then I just draw a triangle that is 45, 45, those two are the same. So if you have 1, 1, and this is square root of 2, right? You can do that. Or, you know, if you want sine of 45, well, the opposite from 45, the adjacent, and the hypotenuse. So you draw the triangle for the 45. Then you get, they want sine. Okay, so sine of 45, its opposite, which is 1, over square root of 2. So 1 over square root of 2, as you rationalize the denominator, that becomes square root of 2 over 2. And that's where that number comes from. Okay?
Is sine always going to be 45?
No. Sine could be anything. Sine of 1, 2, 3, 4, 5, 6, 7, 10, 30. It happened to be that 45 is a special angle. So they could give you sine of anything. But the numbers that we're using on these formulas are numbers are special angles, like 30, 45, 90, 180, 360. You know, those are special angles that we can get measurements of because of the unit circle. Okay, now what about cosine of 30? Well, for cosine of 30, let me go ahead and draw the triangle. And I'm going to say, okay, cosine of 30, I'm going to draw the triangle for cosine of 30. So 30, I have a short leg, which is 1, hypotenuse, that is 2, and the long leg is a square root of 3. So when they ask me for cosine of 30, that's the adjacent over the hypotenuse. So if you look at the value, that is the square root of 3 over 2. Hopefully after a while you don't have to draw the triangles because you already memorized the numbers, okay? So here, going back to the problem, sine of 45 is the square root of 2 over 2, cosine of 30 is the square root of 3 over 2, and then plus cosine of 45, well, that's the same thing as sine of 45, which is the square root of 2 over 2, and sine of 30, if you look at the sine 30, this is the opposite, so that would be 1/2, so that's 1/2, okay? And then at that point, it's just a matter of simplifying The answer, right. When you multiply here, it's a square root of 2 times the square root of 3, that's the square root of 6. And then 2 times 2 is 4. On the second one, square root of 2 times 1 is just a square root of 2, and 2 times 2, that is 4. Since you have a common denominator, that would be 4, you can just combine the numerator numbers. And the answer for that would be square root of 6, just leave it as square root of 6 plus square root of 2 because the inside numbers are not the same. You cannot really add them up. You cannot say this is 2 because this is 1 square root of 6, 2 square root of 6, then you can add them up. That would be 3 square root of 6. But these are different radicals. You cannot combine them. You cannot add them up. No. So you just write them one right next to the other. So the answer here is the square root of 6 plus square root of 2 divided by 4. Now, if you use a calculator, go ahead and get the calculator. And let's check sine of 75, and then check that value that we have, square root of 6 plus the square root of 2 divided by 4. It should give you the same value. Let's go ahead and check that. Okay, so let's go ahead and practice with example number 1. In example number 1, it says, find the exact value for tangent of 15. Okay, so tangent of 15. We only have sine and we only have cosine, right? So I need to get the sine of 15 and then divided by cosine of 15, and that would be the value of tangent of 15. So that would be a little longer in a way. So let's first find sine of 15 and then cosine of 15, okay? Right. Okay, let's add one formula to, let me go right. Let me just add existing.
When it says minus plus, does that mean it has to be the opposite of the one that's used?
That is right. Okay, so tangent of 15. Which two angles add up or subtract to 15?
45 minus 10.
45 minus 30? Okay, so we can use 45 for U and 30 for V, right? Okay, so we can use, yes, tangent of 45 minus 30. So U represents 45, V represents 30. When you plug it in, that's going to be tangent of U, which is 45. And then we use the same sign. Since we're using a minus, we have to use a minus there. Minus tangent of 30 all over 1. And then at the bottom, notice that it's the opposite sign. So here I'm going to use a plus. Tangent of 45, and then times tangent of 30. Now we have to get the values of tangent of 45 and tangent of 30. So did you recall those values? Probably not, right? So let's just draw the picture. 1, 1, square root of 2, and let's draw the picture for the 30, 60, 90. That would be 1, 2, and square root of 3. Okay, so tangent of 45, it's opposite over the adjacent. So what's tangent of 45? Is 1, isn't it? Because opposite is 1, adjacent is 1, so 1 divided by 1 is just 1, right? Okay, so then it's 1. What about, let me just copy that. So it would be 1 minus, what about tangent of 30? 1 over square root of 3, but then you rationalize
33 over 3.
square root of 3 over 3. So it's 1 minus square root of 3 over 3. And then divided. 1 plus, okay, tangent of 45 is 1 times tangent of 30 is square root of 3 over 3. Okay, so then that 1 that we have, we need to combine it with the square root of 3 over 3. So the 1, we need to change it in common denominator 3. So this 3 could be 3 over 3, right? So this could be the same thing. Let me just erase that. That could be the same thing. Let me just scratch it out and I'll say, well, this is just 3 over 3. What about on the bottom? Should we do the same thing? right? It's the same thing, because
So both ones count.
that's right. That could also just be a 3 over 3. And now at this point I can say, okay, so the numerator could be 3 minus square root of 3 over 3, and the bottom could be 3 plus square root of 3 over 3.
Okay, so,
So far, so good? Now, do you recall that when you have a fraction divided by another fraction, you can multiply it by the bottom reciprocal fraction? Right? Okay, so when you have that, what you can have is, you can say, okay, well, that is the same thing as 3 minus square root of 3 over 3 multiplied by 3 over 3 plus square root of 3. And at this point, hi Victoria, I'm so glad you're here. So at this point, we can just cancel out the 3's. Now we cannot cancel out the 3 minus the square root of 3 and the 3 plus the square root of 3, because they have different signs. So let me just rewrite it. That would be 3 minus the square root of 3 over 3 plus the square root of 3. And now at this point, what else can we do? Well, we can remember the conjugate? When you have denominators with a binomial, we have to multiply by the conjugate of that. Okay. So what is a conjugate?
the numerator.
Then
Well, I mean, it's, I'm just trying to say.
What's
that.
conjugate?
No.
when you have the same binomial with the opposite sign in the middle. So the concern is that we cannot have a radical in the denominator, right? We cannot leave the radical on the bottom. So that's what we need to get rid of that radical. So we multiply by the conjugate of the bottom binomial. So we multiply by 3 minus square root of 3. And when you multiply that, you're going to multiply 3 times 3, 3 times negative square root of 3. And then negative square root of 3 times 3, negative square root of 3 times negative 3. So we multiply that. What is 3 times 3? That is 9. 3 times negative square root of 3, it's negative 3 square root of 3. And then negative 3 times the first, negative square root of 3 times the 3, negative square root of 3 times negative square root of 3. So I'm just multiplying with FOIL method.
Oh, you did.
Yeah, this is just FOIL method. So it's negative 3 square root of 3, and then negative square root of 3 times the square root of 3 is square root of, what's 3 times 3? 9. So it's the square root of 9, which is just 3. So it's minus 3. At the bottom, let's do FOIL method. 3 times 3, it's 9. 3 times negative the square root of 3 is negative 3 square root of 3. And now let's multiply square root of 3 times the two numbers. Square root of 3 times 3, 3 square root of 3. Square root of 3 times negative square root of 3,
Negative 9.
that would be negative square root of 9, which is negative 3. Now can you cancel out something here? Can we cancel something here?
Well, there's a
Positive square root of 3 with the negative 3 square root of 3. We cancel those two. And that was the whole purpose of this, to get rid of the radical in the denominator, because you cannot have radicals in the denominator. That would be 6 on the bottom. And what about on the
I
top?
was gonna get this.
It's also 6, right? So when you combine 3, 9, and negative 3, that is 6, isn't it?
Yeah.
6. And then what about negative 3 square root of 3 combined with negative 3 square root of 3?
Is it negative 6
Negative 6
square root of 3?
square root of 3. From the bottom, 9 minus 3
Not 6.
is 6.
Ooh.
Okay, it's getting better.
No.
Now,
Get it wrong.
this is the same thing. It's just long, yes. It's 6 divided by 6, and 6 to square root of 3 divided by 6. Okay, so we can simplify that a little more, right? And that would be the same thing as 1 minus That's just 1, which is square root of 3. And this is the final answer. So never leave radicals in the denominator. You need to move on and multiply by the conjugate. Now let's check that with the calculator. So the mistake was a negative and a negative. That was supposed to be a positive, and just because of that sign, everything was wrong. So be careful, okay? So now on number 2, tangent of 105 is the same thing as tangent of 60 plus 45. Now let's go ahead and follow the formula.
Oh.
Let me just delete all of that so that I can have some space there. Okay, how do I delete? I would like to delete that. Can I just delete it like that? All of it. I just want to delete everything.
On like the little box.
Double tap it.
Double tap?
Tap the box. Or not.
No.
Just send it to me back.
Okay, let me just use another page.
The X right there.
Let me just use another page. Where's the X? I don't see
There's
it.
an X right there on the left on the
Oh,
column.
and yeah, the left, left.
The lid,
Very, very
the
left.
lid, the lid, the lid.
That one? There you go. Good job, Alex. Yes.
The lid, the lid, the lid.
The lid. I was actually saying that yesterday at work. The lid.
I know, right? Teaching new people when they come in. Like the
Really?
lid, the lid, the lid, the lid.
That way I can have some
Well, guys,
space
we're,
here.
we're being recorded a lot. We're still being recorded.
It's still recording. That's okay. Okay.
Sorry.
I'm sorry.
I never said anything, right?
So you have to grab each box, you have to click X, right?
Right. Okay, so here's going to be tangent of 60. It's a plus, so I keep the plus. Tangent of 45 divided by 1 minus, because it's the opposite side, tangent of 60 times tangent of 45. Okay, what is tangent of 60? Well, 60, if I look at the triangle at the top, it's opposite, so square root of 3 over 1. Do you see that? Tangent of 60, opposite over the adjacent. So square root of 3 over 1. Right? So tangent of 60, that is just a square root of 3, plus tangent of 45. Do we know that value? It's just 1, isn't it?
Oh, tangent. Yeah, yeah.
Right? And then it's 1 minus tangent of 60 is the square root of 3 times tangent of 45, which is 1. That is the same thing as the square root of 3 plus 1 over 1 minus square root of 3.
Wait, we're not supposed to do that for the left side? Or
What do you mean for the left side?
like for the tangent 60 plus 45?
I already got tangent of 60. That's square root of 3. From the unit circle, that is the square root of 3. Or from the triangle.
No, I'm talking about like on the left hand side.
What do you mean?
Right there. You don't have to do that? The square root of 3 over 1.
Okay, when you were talking to Yadira, I was pointing to the triangle. That tangent of 60, opposite is square root of 3 over adjacent, which is 1. So that's just the square root of 3.
No, I know, but never mind.
Okay.
I get in trouble.
No, you don't get in trouble. So anyways, you go back to the triangle, you get the values from the triangle. Yadira, don't interrupt with him, please, okay? So anyways, here you put the values, then you have to get rid of the radical in the bottom. What do we need to do here to simplify the bottom? How do you call that process that I'm doing here? We multiply by the conjugate, yes. So we multiply by the conjugate. Let's be careful with the signs. So it's the square root of 3 times 1 is the square root of 3. Square root of 3 times the square root of 3 is the square root of 9, which is 3. Now the second one. 1 times 1 is 1. 1 times square root of 3 is the square root of 3. Then at the bottom, 1 times 1 is 1. 1 times square root of 3 is the square root of 3. Then negative square root of 3 times 1 is negative square root of 3. Negative times positive is negative square root of 3 times square root of 3 is the square root of 9, which is just 3. And then we combine like terms. 3 and 1, that's just 4. the square root of 3 plus the square root of 3 is just 2 square root of 3's. At the bottom, the square root of 3's cancel each other. 1 minus 3, it's negative 2. And then we just simplify that. This is the same thing as 4 divided by negative 2. And then 2 square root of 3 divided by negative 2, because I'm simplifying both of them. Would that be negative 2 minus the square root of 3? Do you see that? Positive divided by negative is negative. Positive divided by negative is negative. 4 divided by 2 is 2, and 2 divided by 2 is 1. And that would be the answer. And now let's just double check with the calculator. For the problems on the bottom, all you have to do is say, okay, what is this coming from? Well, sine 49, cosine 11. 49 is like your u, and 11 is like the v. U, v.
Yeah, we can see.
So, you cannot see? You want me to make it bigger?
No,
Like that?
Well, it's because it was on the projector.
On the calculator?
That.
Okay, I see. Okay, so then if you assign the first angle to be u, the second angle to be v, and then 49 and then v. So look at the formulas. Which one has sine, cosine, cosine, sine? Which property has sine, cosine? Sine? Okay, so this must be sine. And then sine of u is 49. And now you have a minus in this property. What would the sine have in the middle? Look at the formula chart.
negative, plus or minus.
Plus or minus? Okay. If my property has a minus, then I have to look at the sign in the middle, which is a minus. Okay? So if in the middle I have a negative, this is supposed to be a negative. So I have to subtract u minus v. So when I put that 49 minus v, which is 11, and I simplify that, what is 49 minus 11? That's 38. Okay, so then this is just sine of 38 degrees. And that's the answer.
Oh,
Okay?
I like these
Now,
better.
yes, this is just finding out what is the single logarithm or the single function here. Okay, so now what about the second one? You have cosine, cosine,
Plus.
and then a plus. Now notice that for cosine is the opposite sign in the middle. So that's supposed to be cosine, right? Right? Okay, so then this is cosine.
Wait, miss.
Yes.
We don't do the second part too, because there's like sine 49 minus, sine 49 and then cosine 11 minus cosine 49 sine 11.
If you look at the formula for sine, that's the way it's supposed to be. Cosine of u, sine of v. So it is following that formula for sine. Do you see the formula for sine?
Yes.
Okay, it's just following that formula. And now for cosine, do you notice that it's cosine of u, cosine of v, and then sine of u, sine of v. So it follows the formula for cosine. So the sign in the middle, negative plus, in the middle of cosine is plus minus. So I should have, if I have a plus in the middle, then my middle sign in parentheses should be a minus. U is 133. V is 58. So when I subtract 133 minus 58, what is 133 minus 58? 75. So that should be cosine of 75. And that would be the answer. So here we're just trying to find out which is the single function that we need to use. What about for number 6? That's supposed to be what? Would that be sine, cosine, or tangent? That's tangent. So tangent of plus or minus in the middle. It's a minus. Yeah, for 9/11. Okay, you guys. So work on that assignment, please. Just follow the formulas and do what we were doing. Be careful with the sign of page here for tangent. add this formula. Tangent of u plus minus v. Let me change. Tangent of u plus minus v equals, it's tangent of u, and it's the same sign, plus minus tangent of v, all over 1 minus tangent of u, tangent of v. This is minus plus, and the bottom is minus plus. Tangent of u, thank you, tangent of v. Okay, so then once you put sine over cosine and you simplify that formula, this comes up. Tangent of u plus minus on top, tangent of v, and then the bottom is 1 minus plus tangent of u, tangent of v. So if we use that formula for the first problem, which is tangent of 15. So let me go to the